Yesterday we have read about these things, bit depth, and we know why bit depth is important and what is bit depth. So today we will learn raster data in GIS. So raster data is like a detailed grid or image used in the GIS to represent areas where things change continuously, like different shades of grass in the field. This will be more clear. This can be handles raster data capture all the small variation in area, like changes in color or density, which would be lost or simplified into one shape. See, this is a type of the picture, but this can be represented by not by the vector data. This can be represented by the raster data, because here the tree color is different, the land color is different, and the sky color is different. So when we will make a data for this, then we will of course we will make a raster data, because we have to show a color change in this. And how we will make, we will see later. So in this data, some features on landscape are easy to represent at points, lines and polygons. This is the line, and this land area is a polygon because it's representing an area, and this is also a line because it's a linear feature of the tree. In other cases it can be difficult. For example, how do you represent the grassland? It's a very difficult. How do you represent the, because data is represented in the line, points, or this as polygons. What about the variation in colors you can see in the grass? When you are trying to represent large areas with continuously changing values, raster data can be a better choice. So in this case, this is a data. You want to construct a data for this area. Okay, in this lots of the things: tree, land, roads, etc., grass. Okay, when you are using the vector data, the vector is represented by point, line, or polygon. Okay, point and line can be represented here. Suppose that line is, this is road, tree is, this is line, also a line, and some fields you can represent by the polygons. But what will you do for this grassland? Because some vegetation is high, here the low, here is the high, so it cannot be represented by the vector data. So you have to make a raster data for this, because you have to show the color variation and the shades of the color, so that can be used in the raster data. Now the two important things in raster data: what is a grid and mesh? A grid in GIS is a regular pattern of equally spaced cells or pixels that cover a geographic area. Each cell contains a value representing information about that specific area, such as elevation, temperature, or land cover. Regular pattern means cells are arranged in a consistent rectangular layout, which we have seen in the case of the just previous yesterday. Uniform size: all cells are of equal size. Data representation, often used for raster data showing a continuous information like satellite image or elevation maps. Characteristics: a mesh is a network of interconnected nodes, points, and edges that can form various shapes like triangles or polygons. It used to represent a complex surface and structure. Commonly used for 3D models and terrain mapping, where it is represent a complex surface and a structure more accurately than grids. So mesh is used for when you are using a 3D model, then you will use a mesh. But in the case of regular body, you will use this grid. So complex surface is represented by the mesh. A network of nodes and is used for vector data representing complex surfaces and a structure with greater flexibility. This is your mesh. See, irregular body. Here this it's showing a 3D body, and this is your grid. Here the pixels of this is in a rectangular shape, with each pixel has the same value and represented by this pixel 1 color. This color is 1, 2, 3, 4, and each value is this pixel is represented by water, and this pixel by LDA3, SC, LDA3, and whatever this thing, soil. It's a category of the soil. So more about the grid. A grid is a way to store raster data commonly used in history systems. There are two main types because history is the best in the GIS. So main GIS has been developed by the history, which RGIS software is developed by the history. So there are two main types. Integer grids used for discrete data like categories or classes. For instance, a grid might use a different number to represent various land types, example forest, water, urban areas. This can be always represented by the integer grid. Floating grids, it's been decimal grids used for continuous data like temperature or elevation, because here the temperature is 25 degrees centigrade, or sometimes this temperature is 30.1 degree centigrade. Then this can be represented by the continuous data, and continuous data is a floating type points, but in integer is always a discrete type where value changes smoothly over an area. So the representing of the grid, storing a data inside the grid is a two-way, that is integer grid and floating point grid. Integer grid is discrete data which represent the forest, water, urban areas, like this type of the thing, and floating grids like which can represent in the float like temperature or elevation. Elevation 25.5 meter, 10.2 meter. Integer grids in detail. This can be stored in an attribute table that is called the value attribute table. Each unique grid value is recorded here, and value represent a specific class or type. Example 1 for forest, just like a previous this, 1 for water, 2 for this one. This is type of the soil, 3 for this, 4 for this, 5. This is the integer grid. Value represent a specific class or type. Example 1 for forest. Count shows how many cells have the value. Example 50 cells with value is equal to 1. For example, if 50 cells are marked with value 1 indicating forest, the VAT will display value 1 and count is 50 and summarize the grid content. So this is the way for storing a data inside the grid. Grids are essential for organizing and analyzing a spatial data effectively. See, this is the example of the grids. Rows, columns, this things count. This simply value is 1, count is 11. It means 11 soil water body is measured at 11 points, but its category is 1, so value is 1, but count is 11. So just like this let's see. Suppose that this is 1, 2, 3, 4, 5, and all is the water body. Okay, all is the water body. So it's represented by the value is 1, and 1 is represent the water body. But how many count for this one? This is 1, 2, 3, 4, 5. This count for the 5. So this is the counter. Now floating type of this is the integer type of the grid. Now the floating type of the grid. Floating point grids are used for data where values can vary continuously, like elevation or temperature. Unlike integer grids, floating point grids does not use a value attribute table because the value can be any number within a range. Instead, each cell's value directly represents the data at that location. Key points: cell value. So floating types a value VAT value is not given because it's a floating number. So here instead of this there is a another column that is called cell values. In floating point grid, each cell holds a specific number that describes its attributes. For example, a cell values of 10.162 might indicate that the location is approximately 10 meters above sea level. Value range: floating point grids can store value up to this 10 to the power 8, and integer grids store from this to this. This is the limitation of your pixels, but this is a huge number, you cannot exceed this. Coordinate system, this is very important. Grid follow the same coordinate system as other geographic data. Rows and columns align with the x and y axis makes it easy to determine the location and area covered by the each cell. So suppose that this is a grid, okay, and suppose that this is a floating type of your data has been stored. Then this is the floating, in this floating type data there is a cell value, there is a count value, but there is no VAT value, okay. But besides these two, in addition to these two values, there is a x and y. X and y its position, it's called the coordinates, okay. So it is showing its position in space where it is situated. Suppose that this is a data has been stored for the Calcutta region, so it must have a coordinates. So coordinates value information is also stored in this grid and grid mesh and this floating because floating and your integer is a type of the data way to is a method to store a data in a grid. And there is another column, naming caution. When naming grids, avoid spaces and special characteristic multiple band grids. Yes. No, sorry, this is not minus 3 point this is a dash which is representing arrow. This is different. No, it's not, it's a range can store data. Suppose that your value is suppose that you are storing a data is 2.5, okay, degree centigrade. This is the one. So you make a in a pixel, you make a lots of the column because it should make a lots of the column in your pixel. So it's up to you the column and row. It's from 3.4 10 to the power 38 to 3 point oh sorry, this is minus 3.34 because floating can be minus, okay, no, don't worry. So from minus to, but you cannot exceed this number, you cannot make this number to this is the you can say that the number of quantity insert in a pixel. So this number, because suppose that the Excel has a row and column, okay, but its limitation how many row you can insert in this limitation you can see here without see Excel row limitation. The row limit of Excel is this. Beyond this you cannot enter any data to this. So that is same type in this things. These things. So here, similarly for the integer data, the integer cannot be exceeded in these things. Integer gets can store values from 2.4 to this one. Hello, are you getting this? Yes, yes. Floating means float means what? Float means decimal, but it's a decimal. How many decimals can be stored in this way? The decimal can be minus 3.4 to plus 3.4 to up to the 10 to the power 38 values. Beyond this, the pixel cannot store the data. Same for the integer. Integer grids cannot store the. Of course, this is a huge number, and you cannot reach up to this number because I don't think so. Beyond this anything, but the limitation will check then up to this. Maybe in future the limitation has increased. Floating point grids offer a flexible way to represent complex continuous data, making them crucial for many applications. So, grid structure. Grid in a GIS use a specialized data format to efficiently store and manage large amounts of spatial information. Tiled raster data. Grids are made up of rectangular blocks of cells called tiles. So, have you heard about the tiles when you if you your background is remote sensing or something this, then oftenly you heard about or when you're going to download a satellite data, then one term is the tiles. Then what is the tiles? Grids are made up of the rectangular blocks of cells called tiles, just like this. this this is suppose that this is an area, very huge area. So satellite, this is your satellite, okay. Then this cover this area, okay, this cover area. Then this data is stored in a grid format, gridded data. So this is a gridded, and grid is made up of the cells are pixels. I have explained clearly yesterday. So this, for this area, this is a one tiles. Similarly, if satellites move here, take another data is sort, then this is a second tiles. So you have to download the different tiles for your area, and then merge this, and then we will get the full raster data of this area. Have you understand these things? Hello. Tile size. When creating a grid, the tile size depends on the grid dimension. Although tiles can be extremely large, up to this number. Most grids fit within a single tile. If a grid exceeds the size, it splits into multiple tiles. That's in the case, suppose that your area is very huge, then it's split into multiple tiles. Then you have to download multiple tiles for your study area. Storage and access. Grids are organized to support both sequential and random access. This means you can efficiently analyze large data set without worrying about how the data is physically stored. So there is no worrying about how data is stored in the grids, and this is a very complex things, how data are stored in a grids or pixel, because satellites are which has been constructed not by a simple it's a very complex thing. So our aim is not to understand the how these are stored in the data. Our aim is to just collect the right data from the satellite and analyze it through GIS. You just interact with the grids as if they were continuous image without needing to worry about the underlying tile and block structure. That's I have written here. Compressor and efficiency. Grids use a smart compression method that adjusts based on the data. This method ensures that both simple and complex data is stored efficiently, saving disk space. Operation on grids, whether involving single or multiple layers, are handled smoothly thanks to the adaptive compression. This is the advantage of the grid. Overall, this grid structure allows for efficient storage and processing of large amounts of spatial data, making GIS application powerful and responsive. Now, grid block structure. Grid block structure is this type. This is your grid. A, B, C, D as a cell, and in cell there is a data information. That's why you see block strip, column and row. This column and row cannot exceed that numbers which I have shown there. Cannot exceed. So this is the way for the store a data in a grid, and this is no need to go in a deep because it's a very complex algorithm and it's beyond our field. We have to only collect the data and interpret the data and analyze the data through the GIS. But how this data is stored in this, how in a cells and in a pixels data is stored, and what is its limitation. Just see, it's from this picture it's clear. From minus to something this, then you can go from here to there, but cannot make a more than this data. A grid in ArcInfo workspace is organized as a directory. Similar to how a coverage is stored. This directory contains various tables and files that hold essential information about the grid. Grid directory. The grid is stored in a dedicated directory with. Of course, this is a directory because grid take the information of your data set. Like 1 means forest, 2 means soils, and 2.5 is your temperature, and 3.1 is elevation. That's the example. So this information is stored in the your this thing. Suppose there is a two difference between these things. Suppose you are making a data set on Excel. Okay, give the x and y information, its coordinates information, and for tree is 1, 2, 3, 4, and here the symbol defined. The one is a thick tree, thick group trees. 2 is a grassland. 3 is this is a data set. This is not a grid. When you make a this data set and process in your GIS, then automatically this convert into your grid. Suppose that you are using this data as a vector or as a raster. When you are used as a raster, then it's a must lie in a area because it's have a spatial data information. Then it's automatically convert in a cells. You will see in this GIS software. So that data is stored in a according to their arrangement. Now there is another table, BND table. This table stores the boundary information of the grid, defines this boundary condition, this boundary because x, y. So by that automatically by default it is making. HDR file. The HDR file contains detailed metadata about the grid, such as this data. You will see when you will open the raster data, then this type of the tables are available in this. So what is the meaning of this? HDR file contains a detailed metadata about the grid, such as the cell resolution, size of the cell, and the block factor, which affects how data is grouped in the processing. STA data table. This table holds statistical information related to the grid, such as the minimum, maximum, and average value of the data. VAT table. VAT table is, I have already explained, this is a discrete type of the data, that is your integer data. The bat value attribute table stores attribute data associated with the different zones or categories within the grid. Suppose that this is the zones of the forest, zones of the grassland, zones of the this water body. The log file tracks the activities and changes made to the grid over time. However, this file may not always be present, especially in the if the grid created using RGS operation instead of ArcInfo workstation. The file 0 w0110.pdf. This is a tile file. Example of the file store the actual cells data for the grid. The cells contain the value that represent the different attributes of category space. This is an example known. Index file. The index file work as alongside whenever you will go for downloading or and analyze this in any JS software, then this type of the terms will come. I just want to introduce to you this. What is the meaning of this? So what is the BND table? The BND table defines the boundary of the grid, stored as a rectangular in a map coordinates. It captures the minimum and the maximum coordinates of the grid, pinpointing exact location of the lower left and upper right corners with the double precision. HDR file. The HDR file is a binary file that stores essentially grid information like cell size, grid type, integer or floating point, compression method, blocking. You will see these things. I will show you when we will process the this raster in QGIS. STA table. The STA table contains a statistical data information. Here is a special codes like -1 and -2 are used to indicate uncalculated statistics or grids with only no data cells. So no data cells for uncalculated, then there is some -1 and -2 values are. It means no statistical value, and the data is there is no data. It means missing values are present. So this is your grid data structure: workspace, soil grid, weak grid, and road. A type of the data structure in your grid. So this is the way for record wet table and for continuous data for integer 1 2 3 4 and count is this. Now grid stack. Stacking is a very important thing in a GIS. A stack is a powerful tool for multivariate analysis. What is the meaning of the multivariate analysis? Suppose that there is a term that is a multi-point statistics. This is another thing, and multivariate analysis is another thing. Multivariate means multi means more than one, and variate means more than one variable, and multi-point statistics means this is your points. And in some algorithm, the restriction for the only this will take the processing for 2 points, but in MPS there is no restriction. This will take randomly any points of this. So a stack is a tool for a multivariate analysis consisting of an ordered set of spatially overlapping grids treated as a single entity. This allows for advanced operations such as a cluster analysis, classification, and principal component analysis across multiple layers. This is the way. This is the layer 1, layer 2, layer 3, layer 4. So stack this one and make a single layer. Layer 1, layer 2, C. Then layer 1, layer 2, layer 3, and this is your stack. So this stacking property define the cluster analysis, classification, principal component analysis, whatever you want you can do with the stacking property. We will do also some practical or grid stacking. So how grid structures are formed And what is the algorithm behind this? First, the layered structure. Each layer in a stack correspond to a grid ordered in an index number. So for grid stacking, the must thing is that layer 1 have a same dimension. It means its matrix 2 into 5. Then layer 2 must be 2 into 5. Layer 3 must be 2 into 5. Layer 4 must be 2 into 5. Otherwise this will not stack. Each layer in a stack correspond to a grid ordered by an index number. Map extent BND, I have define spatial boundaries where the layers intersect. Cell size, the stack cell size defaults to the coarse layer. Can include data type combination of real integer data type. So the next thing is the projection. What is the projection? We will see that suppose that one layer has the projection is WGS84, then must be layer 2 be also WGS84. Layer 3 must be one. Suppose that one layer has UTM projection and another has a WGS84, then stacking cannot be done. Error will come. Overlap and competition. The boundaries of the input layer of a stack can overlap fully, partially, or not at all. However, only the overlapping areas form the stack in previous case, and this is where computations for multivariate analysis occur. If there is no common overlap, the stack remains empty and no analysis is performed. Flexibility with data type. While you can combine different data types, categorical or continuous with a stack, it is essential to consider what these values represent before performing analysis. The type of data in the stack often determines the nature of the output. Projection integrity, projection information, which I have already told you, projection must be same. So this is the grid stack is stored a directory structure similar to a grid coverage. The stack directory contains two key files. The first is info STK table, an external table storing the names and index value of the grids that make up the stack. ASCII PRG file. It means ASCII PRG file. If present, the contains the position information in the stack. So when you doing the multi-layer stacking, this is one, this is layer 2, and so this is your stacking part. So automatically in your which file has been generated, two table has been generated. One is info sticky table and ASCII query table. So what is inside this? That contains the projection information stack, and second is the naming of this overlapping. The grids that form the stack are not stored within the stack itself. They remain as individual grids in your workspace. This allows a single grid to be used in multiple stacks, ensuring flexibility and efficiency. The STK table tracks the names of these grids and their corresponding index values. So this is the table when you are doing the stack. Grid G3 grid, J1, J3, J5, index 1 to 3, record 1 to 3. Index indicates that the position of the grid within the stack. Grid lists the name of the grids comprising the stack. So storing a grid stack. So there are two things: real-time updates and projection information, PRG information. So real-time updates means since the spatial data of input grids is not duplicated in the stack, any updates to the input grids are automatically reflected in the stack. The STK file, being an information file, is accessible and can be enriched with additional terms for descriptive purpose like storing data and collection type. So projection information, the PRJ file, there is whenever you make a save file or other file like something this type of the polygonal file, there is a file is called a PRJ file. You will see lots of the file has been downloaded, and one file is a PRJ file. The PRJ file is the projection information file, and this is an important file. When present contains the projection details of the for the stack. If the projection is unknown for all input grids in the stack, the no PRJ file is created. So whenever you do the stacking, things is that ensure that the projection is the same for all layer. If projection is not given for one layer, then remove the projection for all layer. Then finally your stack and take this stacking value and give then this projected value. This is the name of the grid stack cannot be stored using space, cannot start with a number, and cannot be longer than the 9 character. This is very important. You cannot give a grid name with 9 character, otherwise this will come make a error. And now come to the no data. No data is generally related to the missing value. No data represent the areas without valid data. Example, borders, backgrounds, display. Suppose that this is a here the written things. What is no data? This is your data pixel value, but in background this is the white. There is no meaning of this. Nothing is there. So, but when you will convert in a data, then this will be shows that 1, 2, 3, 4, and this will show that the minus 999 minus 99 value is for your background value. There is no meaning for this. That is called the no data. Display choose so the no data areas with a specific color or no color. That's here most of the case. This can be represented by minus 999. It means the no data. You will see in your some gridded data like IMD gridded data. You will see this type of the structure because that data in a binary format. Okay. Option ignore no data and compute value using available data. Ignore return no data for the location. Estimate if a value if no data is not. So in algorithm you have to give a the value for no data. Ignore if the value comes for minus 999, or the best way to reconstruct your data set, remove the all no data from your binary data and then do for this. See, this is your data 1 2 3 4. This is your data and this is your no value of this. This is a no data, so ignore it. This then the background is looking white. The image on the left shows a no data areas with a black background, and the image on the right shows that the same area using a no color. So this is the information of the raster data, and I hope if you have any question related to raster data, please ask. Now I will jump to the vector data. Then we will see the important interface of the QGIS and do some practical on this. Have you any question on raster data? Hello. Okay, done. Yes, we will go for the practical, because without there is two things in the GIS. One is a raster, another is a vector. So you have understand the how vector raster data is looks like. Raster data is must be in a grid or mesh. So gridded data is in your continuous and discontinuous data you have seen. So you can easily understand the what is the raster, because lots of the column when you will put the data inside this, many times ask raster or vector. Then you have to distinguish between the raster, what is the raster and what is the vector. Then I have explained everything of the raster, what is inside, what is the value of this, and what is the meaning of the no data, and etc. So similarly we will explain the vector data, and then we will see the some interface of this QGIS landing page of this. So vector data, just little bit about this vector data. What is the vector data? Then enough time we have, then we will do this practical paper. So vector data provide a way to represent a real. If have you any problem in georeferencing? Have you done? Okay. Vector data. Vector data provide a way to represent a real world feature within the GIS environment. A feature, suppose that whenever comes in the mind of what is the vector data, then this is a feature. Feature means it's a shape, it's a geometry, line, polygon, point. Okay, a feature is anything can you see on the landscape. Imagine you are standing on the top of a hill, looking down you can see houses, roads, trees, river, and so on. Each one of these things would be a feature when you represent them in a GIS application, because each have a fixed geometry. River is a linear feature, trees have a linear features, house have a box feature, that is a polygon feature, roads have a linear feature. Vector features have attribute which consist of a text or numerical information that describe the features. See here, this is the line feature, this is the road, this is the land. Here this some houses or trees are there. So this is this forest feature, this is a polygonal feature. So vector data defined for this feature. Looking over a landscape, you can see the main features such as roads and houses and trees. Different feature in vector. Vector point feature. A point feature is described by its x, y, and optionally z coordinates. The point attribute describe the point. Example, if it is a tree or lamp of a post. Vector polyline feature. A polyline is a sequence of joined vertices. Each vertex has a x, y, and optionally z coordinates attribute describe the polyline. And the third one is the vector polygon feature. So a polygon feature like a polyline is a sequence of vertices. However, in a polygon, the first and last vertices are always the same position. See here, this is your polyline. This is your polyline. See, it's a line feature, but it's a cover and area. But it's a polygon. It must be a starting and ending must be a intersect. And this is a point. X is your point feature. So this is the way for, and key difference between vector and raster. So this is the very important. After then we will go for QGIS. The first is data representation. Vector represent spatial data using discrete geometric shapes, points, line, and polygons to depict the feature like cities, roads, and lakes. Raster represents spatial data such as continuous grid of cells, pixels, which each cell has a value representing information such as elevation, temperature, or land cover. Now come to the precision. Precision in a vector data provides a high precision in defining feature boundaries, making it ideal for application requiring detailed accuracy like cadastral mapping. And in the case of the raster, precision depends on the cell size. A smaller cell increase detail but also increase the file size, making it less precise for feature boundaries compared to the vector data. File size typically has a smaller file size since it stores only the coordinates of features and associated attribute data. Raster often results in a larger file size, especially at high resolution, because it stores a data for every cells in the grid. Data analysis. Vector best suited for analysis involving discrete features such as a network analysis, proximity analysis, and overlay of operations with complex boundaries. This is the best in a Google map. Suppose that you want to make a traffic data analysis, then you have to use the vector data, because it's a just give the attribute table, then because its size and these things are raster data ideal for analysis for continuous data such as surface analysis, example elevation and slope, image processing and density. Similarly, scalability, easily scalable without loss of quality, feature retain shape and detail regardless of the zoom level. Raster quality diminishes when zoom in or out. The image can become pixels when enlarged beyond its original resolution. Editing vector easier to edit individual features as each feature is distinct and can be modified without affecting others. Editing is more challenging in raster data, especially for small areas that involves changing the value of individual cells. Data type be best suited for the data that is categorical or discrete, such as the boundaries, roads, and landscape. Raster more appropriate for the continuous type of data, such as temperature, elevation, or rainfall, where data values change gradually over space. Storage format, this is very important. Common formats include say file .shp. Whenever you will see the .shp, then remember this is a vector type, or GeoJSON and KML. KML is a Google Earth Engine's data file. Then this is your vector. Raster